algebra, we are actually going over, if I can get to the right page here, CO46. And this is going to be the first, boys, Liam, Blake, quiet please. The first of 5 objectives that deal with operations involving polynomials. Okay. This first one is going to deal with addition and subtraction. The next 3 all deal with multiplication. That's kind of a big one. There's lots of different situations that can happen there. And the last one deals with division. Okay. But if you understand CO42, remember Oxenoid, how we kind of combined equations, okay, with solving for a system. And if you understand CO45, the whole like term polynomial thing, then this should be very smooth. Right. Step 1 is to first, let me scroll down so we can get the steps on here and do an example together. But step 1 is write each expression in standard form. Write each expression in standard form. And if you recall, standard form means that the exponents are written in greatest to least order. Okay? So looking at our first example here, 3x squared plus 5x plus 9, is that written in standard form for you? Yes, right? Our powers go 2, then this invisible power of 1, and then your constants last. The second one, 8x squared plus 12x plus 1, is it written in standard form? Yes. The powers go 2, and then 1, and then your constant, right? So sometimes you don't have to worry about it, but make sure they are written in standard form, okay? Step 2 is we're going to align each expression, I should say align the expressions. Align the expressions vertically. Leaving spaces for unlike terms. Okay? Align the expressions vertically, leaving spaces for unlike terms. So that first one there, our first expression is 3x squared plus 5x plus 9. Is there an x squared term in the second expression as well? Yes. Okay. So those 2 terms are going to be lined up vertically. 3x squared and 8x squared go on top of each other because they can be combined. Okay. The next term in my top expression is a 5x. Is there an x term in the second expression? Yes. So they will be aligned vertically as well. Plus 5x and plus 12x. And, because we're starting pretty basic here, there's a constant in each of them also, and so those constants get aligned vertically as well. So we have 3x squared plus 5x plus 9, our first expression, and then below that, lining up those like terms, 8x squared plus 12x plus 1. Okay. Yeah?
It's not exactly how it's written.
It's written horizontally. We are aligning them vertically. Okay, but yes, it is exactly how it's written. Again, we're starting pretty basic here, just so you can kind of get the process down. Okay, so in this case, we don't have any unlike terms to deal with because they all have a part. They all match up, right? And then we look at our symbol, our operation. What are we doing? We're adding these, and so step 3 is simply add or subtract the like terms. Okay? Add or subtract the like terms. And you do this just like we did in Oxenoid in PO42. We have 3x squareds. We're adding 8x squareds. How many x squareds do we have in all? 11. Okay? 11x squared. Our next step, we have 5x. We add 12x. How many do we have in all?
12. 17.
17. 5 plus 12 is 17. And then we have 9. We add 1. We have close 10. And there is our answer. Okay? We can't combine any of these terms with each other because the powers aren't the same. We have no equal sign, so we're not trying to solve for x here. It's written in the standard form. We're done. Okay. Usually, there's always a few kids that want to check out before even trying this because it looks too hard. But really, it's nothing you haven't done before, right? You've aligned expressions. You've added before. You've looked at like terms, standard form. It's just kind of applying it in a different situation. Okay. But I hope you agree that, as far as you may have looked at this and thought, oh my goodness, what are we doing here? It's pretty familiar with things you've done in the past. The second one, 17x minus 4 and 9x plus 10. That's not. 17x minus 4 is our first expression. And below that, we're going to put 9x plus 10. This 9x matches up with that 17x, so it goes right below it. And that constant 10 matches up with our constant negative 4, so it goes right below it. Again, we have not yet dealt with these unlike terms situation here. Okay, we'll get there in the bottom two. But these two both have partners. Okay. Again, we're adding, so we're going to circle this just to remind ourselves, put it out in front. And who's confident in what you get from this, Abby?
26x plus 6.
Good. 26x, which is 17x plus 9x. And then negative 4 plus 10, Abby said plus 6. That's because negative 4 plus 10 is a positive 6. And that would be our answer. Okay? Notice our exponent didn't change here, right? It's not like we got 26x squared. Here, when we added x squared, it's not x to the fourth. Your exponent doesn't change. Your variable doesn't change, right? What changes here is how many you have, the coefficients. Just like we saw in CO45, when you combine those like terms in the individual expressions, right? Questions so far? Okay. Next set of two here. We have our first subtraction situation. Our first expression is 9x cubed. Then we jump straight to a constant. Our second expression, 15x cubed plus 3. Again, we're lining up those like terms. X cubed with x cubed, constant with constant. The difference is this time we're subtracting.
Yeah, because it's the middle one.
Okay. Yes, you look at the operation between your sets of parentheses to decide what goes over here, if you're adding or subtracting here. You have 9x cubes, you subtract 15x cubes.
Well, is 0 a number?
0 is a number.
Negative 6.
Negative 6. 9 minus 15 is negative 6x cubed. Right? It's not x to the 0. The power doesn't change. The variable doesn't change, just the coefficient. And then looking at our constants, remember to go back to this sign every single time. 4 minus 3. It's not going to be plus 7. It's going to be plus 1. Okay? Don't fall into the trap of just going straight down. Go back to that sign each time. 4 minus 3 is a positive 1. And we're done with that one. Okay? Questions? Because now we're about to dive into what happens when you have those unlike terms that I mentioned in step number 2. But these first three kind of basic, straightforward ones, are there any questions that people have? Okay. So the next one, notice that in our first expression, we have an x term, but no x squared term. In our second expression, we have an x squared term, but no x term. Okay? You might be tempted to put that 5x squared beneath the 13x, but why can't you if we're adding and subtracting these?
Because they don't have the same.
They're unlike terms. So if you look back at step number 2, it says align each expression or align the expressions vertically, leaving empty spaces for those unlike terms. When I write my second expression, I've got to put my 5x squared out in front over here, kind of its own column. Okay, because it can't be combined with the x's, it can't be combined with the 10s, it's got its own column over here. And then, because my second expression doesn't have an x x term, I leave an empty space, and my positive 2 is aligned with my constant. Okay? So here's an example of having unlike terms and leaving those empty spaces so we don't combine things that can't be combined. Now, a trick that you could use, some folks like to fill in these empty spaces with zeros, right? Because if that second expression doesn't have any x's, that's like saying it's got 0 x's. And if our top expression has no x squared term, it's like we have 0 x squareds. And it's not only is it just a reminder to kind of help us remember that we're leaving that empty space for a reason, but also, yeah, go ahead.
Wouldn't you like subtract the two equations?
The two what?
The two equations.
You are subtracting them, yes. That's my next step here. We are subtracting them, so it goes here. But the value of putting this 0x squared here is that you have to actually remember you are starting with no x squareds, and you subtract 5. What's 0 minus 5? Negative 5. Folks that don't put the 0x squared up top here tend to just bring the 5x down because they figure, oh, there's nothing to combine with, I'll just bring it down. But you're actually subtracting 5x squared from nothing, which will give you negative 5x squared in your answer. Okay. Then 13x's, take away none of them, we still have
12.
close.
No, because the x represents 1, you said.
It doesn't. If there's no coefficients, it means you have 1x, but this is a 0 here. And the reason why I put this here is because there are no x terms in that second expression. So if it was just x by itself, yes, it'd be 1. With that 0 in front, it does mean you don't have any. Okay? And then, careful with these constants. It's not negative 10 plus 2, it's negative 10 minus 2, which is actually negative 12. Your time was coming, you just had to wait. So here's where it gets a little bit tricky with the signs and the unlike terms, things like that. But if you take the time to write in what's actually going on here and pay attention to that operation every time, you should avoid most mistakes. Okay.
Why is it a negative 13?
Because you start with positive 13x's and you subtract nothing. That's different than starting with nothing and subtracting 5. Okay? 0 being kind of the first number in subtraction is different than 0 being the second number. That's a good question, though. Any others? Okay, second page. What looks particularly worth our time? Not the last one. Don't spoil the fun. Jay.
Second one, first row.
Second one, first row. Okay. We do have some unlike terms here. If I kind of run down the line, I can see my first expression has a cubed, a squared, and a constant. My second expression has a cubed, a squared, then an x, then a constant. So when I write my first expression out, 10x cubed minus 13x squared, I'm going to leave a space for that x term because my second expression has it. And I'm even going to go so far as to put in a 0x, just to remind myself. Okay. Then my second expression, it has an x cubed term for x cubed. It has a negative 2x squared. It has a 6x, and it has a negative 16. Again, line up all those like terms. Our operation is addition. And so when I add these, 10x cubes plus 4x cubes is 14x cubed. Negative 13 plus negative 2. It can always be a little bit trickier with dealing with the negatives, but negative 13 plus negative 2?
12. 16. Negative 16. Negative 15.
Negative 15 x squared right? Adding a negative is the same as subtracting, and negative 13 minus 2 would be negative 15. 0 x's plus 6 x's is 6 x's. And 12 plus negative 16, or 12 minus 16, is negative 4. And that would be our final answer. Okay. Pick one of the subtraction ones to do next year.
Bottom right.
Cole?
Last one.
Is that a subtraction one?
Yeah.
Any other questions on this one here? Okay. I want to see if the last one has what I'm looking for. But yes, it does. We can do this. Okay. So for starters, I mean, take a look at the way that first expression is written. Step number 1 said make sure each expression is written in standard form. Is that first one written in standard form? No. Its largest power is 15x to the 5th. So that should come first. I'm going to start way over here because I have to write bigger than you have to. Okay. 15x to the 5th. Our first expression doesn't have an x to the 4th term. Does our second one?
Yeah.
Yes. So I have to leave a space. Our first one does not have an x cubed term. Does our second one? Yes. So I have to leave a space. This does have an x squared term. I'm just going to write this in here now, just so I spatial reasoning here. No x to the 4th term, no x cubed term. We do have an x squared term, minus 18x squared. We do have an x term, and we do have a constant. Okay? Everything written out in the standard form. Powers, 5, 4, 3, 2, 1, constant. Okay. Second expression, there's no x to the 5th term, so I'm going to start this out by putting 0 x to the 5th there. I do have an x to the 4th term, so that's going to go beneath my x to the 4th term for the top one. I do have an x cubed term, so minus 8x cubed. I do have an x squared term, plus 3x squared. I do have an x term, and I do have a constant. All right, and we are subtracting these. This time I'll do it in blue because I got that red number out in front there, so just to differentiate. There we go. 15x to the 5th minus nothing is what?
15.
15 x to the 5th. Here's where you got to be careful. 0x to the 4th minus 9x to the 4th.
Negative 9.
Negative 9x to the 4th. Again, that 0 being the first number in a subtraction statement changes things. It's different than 0 being the second number. And you start with nothing, subtract 9, that gives you negative 9. Here's where things really get fun.
Negative 16.
0 x cubed minus negative 8.
Negative 16.
What happens when you subtract a negative? Wyatt? It's addition. So really this says 0 plus 8x cubed, which is positive 8x cubed. Okay, pay attention to those signs. This is something that attention to detail, right? Very important. Negative 18x squared minus positive 3. How many x squared is that?
15. 16. 14.
Negative 18 minus 3.
13.
Negative 21 x squared. Negative 18 minus positive 3 is negative 18 minus 3, negative 21. Negative 20 minus negative 20. Let's write that one out here. Negative 20 minus negative 20. What happens to that minus a negative? It's actually adding. So this becomes negative 20 plus 20, which is 0. They cancel out. Nice. And then the constant 3 minus 3. That's 0 also. Negative 3. What? 3 minus 3 equals 0. 3 minus 3 equals 0. So your final answer with what you have down here, you can't go any further because there are no like terms to combine. and you're done. Okay? What do you think? If you pay attention to detail and you have success with CO45, and to an extent PO42 as well, it's really there's some familiarity here. So good. Your homework due Tuesday is to finish CO46. We will pick this up next week. Have a great Easter, good Friday. What's that? Yes, you do need to do the time for you at the bottom. Look at CO44. We covered it there.
Wait, I think
What? All right. That's what I'm at.